Okay, today we're going to be talking about acid rain. So first off, what is acid rain? Acid rain is a broad term referring to a mixture of wet and dry deposition from the atmosphere containing higher than normal amounts of nitric and sulfuric acids. The precursors or chemical forerunners of acid rain formation result from both natural sources, such as volcanoes and decaying vegetation, and man-made sources, primarily emissions of sulfur dioxide and nitrogen oxides resulting from fossil fuel combustion. Acid rain occurs when these gases react in the atmosphere with water, oxygen, and other chemicals to form various acidic compounds. The result is a mild solution of sulfuric acid and nitric acid. When sulfur dioxide and nitrogen oxides are released from power plants and other sources, prevailing winds blow these compounds across state and national borders, sometimes over hundreds of miles. So why is this important? Acid rain causes acidification of lakes and streams and contributes to the damage of trees at high elevations and many sensitive forest soils. In addition, acid rain accelerates the decay of building materials and paints, including irreplaceable buildings, statues, and sculptures that are a part of our nation's cultural heritage. Prior to falling to the earth, sulfur dioxide and nitrogen oxide gases and their particulate matter derivatives, sulfates and nitrates, contribute to visibility degradation and harm public health. What do we currently know about the effects of acid rain? Acid deposition penetrates deeply into the fabric of an ecosystem, changing the chemistry of the soil and streams and narrowing, sometimes to nothing, the space where certain plants and animals can survive. Because there are so many changes, it takes many years for ecosystems to recover from the acid deposition, even after emissions are reduced and the rain pH is restored to normal. For example, while visibility might improve within days and small or episodic chemical changes in streams improve within months, chronically acidified lakes, streams, forests, and soils can take years to decades or even centuries in the case of soils to heal. The leading controversy is debating whether or not our government should increase the regulation of air pollution. While some action has already been taken, such as the Clean Air Act of 1963 and the Acid Rain Program of 1990, deciding when, how, and if more needs to be done is a battle in Congress. So what are we going to do in the future? As emissions from the largest known sources of acid deposition, power plants and automobiles are reduced, EPA scientists and their colleagues must assess the reductions to make sure that they are achieving the results that Congress anticipated when it created the Acid Rain Program in 1990. If these assessments show that acid deposition is still harming the environment, Congress may begin to consider additional ways to reduce emissions that cause acid deposition. It may consider additional emission reductions from sources that have already been controlled or methods to reduce emissions from other sources. Congress may also focus on energy efficiency and alternative energy. Implementation of cost-effective mechanisms to reduce emissions and their impact on the environment will continue to evolve.